Welcome to our channel. Please watch the video to the end, leave a like, and subscribe to support us. When we think of a planet, we imagine an object orbiting a star, like the planets of the solar system or the thousands of exoplanets discovered orbiting other stars. However, there may exist planets that do not orbit any star and are not part of any planetary system but simply wander through space. As strange as it might seem, the answer is yes. These planets have been called by many names: wandering planets, nomadic planets, orphan planets, interstellar planets. But, regardless of the name we use, what's important is that we know they exist because they have been observed. But how did we discover them and how do we think they formed? They might even host some form of life. Let's try to understand. First, let's understand how a planet that does not orbit a star might form. There are fundamentally two ways. One is the way stars themselves form, from the collapse of a large gas nebula. If the mass is not sufficient to trigger nuclear fusion reactions in the core, then this object becomes a failed star. So, if we like, we can define this object as a planet. It would simply be a very large gaseous planet that does not orbit something else. However, there is another possibility that perhaps is a bit more interesting and closer to what we usually define as a planet. Planets form around a main object, a star, from the collapse of this nebula and the material that remains around the star. Once the planetary system is formed, it is not as stable as one might imagine. The already formed planets can be expelled from a planetary system through interactions, for example, with other giant planets in the system or by the close passage of another star. These expelled planets would no longer be tied to a star and could be not only very large gas planets but also smaller ones similar to Earth. So, from a theoretical standpoint, it is entirely plausible that there are planets out there that are not gravitationally bound to any star. Computer simulations show that this is less rare than one might think. The question we can ask at this point is, how do we know if they really exist? How can we observe these free-floating planets in the dark of space? As we know, it is very difficult to observe planets orbiting other stars because planets are very small objects and are not luminous, so we normally only become aware of their existence through the star around which they orbit. There are two main methods for observing planets in another planetary system: the transit method, observing the dimming of the star's light due to the planet passing in front of it, and the radial velocity method, which involves observing the change in position of the star in our direction due to the gravitational interaction with the planet or planets orbiting it. But naturally, these methods cannot be applied to planets that float freely in space and do not have a nearby star. Another method that can be used is called the microlensing method, or the gravitational microlensing method. Essentially, the gravitational lensing effect comes from the theory of general relativity by Einstein and is used in many different ways in astronomy. It is based on the fact that when a massive object comes between us and another more distant luminous object, this massive object acts as a lens because it curves the surrounding space and thus the path of the light rays from the object beyond is modified. And this modification of the light path, this lensing effect, is observable in the case of wandering planets. We can use this method of gravitational microlensing if the planet randomly passes in front of a background star and we see the star's light altered by the lensing effect. We can deduce that there is a planet in the middle. To be clear, the star naturally is not a star around which the planet orbits, because the planet does not orbit any star. It is simply a distant star that happens to be right along the path traveled by the planet. Naturally, the light variations predicted in this case are extremely small, so a great sensitivity of the instrument is needed to notice them. The other problem is that these microlensing events are completely unpredictable and random. It can happen that a planet passes in front of a star and causes this lensing effect, but we do not know when. Moreover, these events in the case of such a planet last very little, less than a day, even just a few minutes, and do not repeat themselves. So we have to be very lucky to notice them. But how then do we discover wandering planets with the microlensing system? Well, we watch many stars at the same time, millions of stars, and hope that some of these stars' light is modified by this lensing effect. What is done to increase the chances of observing this effect is to look towards the center of our galaxy, where the density of stars is greater, and thus we are able to monitor more stars simultaneously, a sufficiently large number to have a significant number of events. Indeed, Using this technique, the first wandering planets were discovered in 2011. The next question we might ask at this point is, how many wandering planets exist in our galaxy? This is a difficult question to answer because the statistical sample is still incomplete. However, by putting together the observations that have been made so far with theoretical models, the general opinion among astrophysicists is that there may be tens or hundreds of billions of wandering planets in our galaxy. These wandering planets can be of all sizes and dimensions. They can be giant planets like Jupiter, but also smaller planets similar to Earth. And in fact, it is expected that smaller planets are much more numerous than giant planets. Naturally, however, the smaller planets, although more common, are also much more difficult to observe. So, there are all these wandering planets roaming our galaxy in space, completely dark because they have no nearby star to light them up and warm them. It might seem impossible to imagine that on such a planet there could be conditions suitable for life, or even life itself, but in reality, it's not really so. Several studies suggest that even wandering planets, in theory, could be habitable. Habitable, in astronomy and astrobiology, simply means a planet that could have liquid water. But how could a planet far from a star, and therefore not heated, have liquid water? In fact, there are other possibilities because planets, all planets in general, have a source of energy, a source of heat that comes from within the planet itself. This internal heat source can come from the great energy released at the time of the planet's formation, thus gravitational energy that was subsequently converted into heat. Or it could be caused by the presence of radioactive elements in the planet's core, which can be in sufficient quantities to provide a certain amount of energy and heat the planet's interior. Naturally, this internal energy, as we know in the case of Earth and generally in the case of other planets, is thousands of times smaller than the light that comes from a star. So generally, this energy alone would not be enough to make a planet habitable or to keep the planet's water liquid if the planet floats in the dark of space. This internal energy would be dissipated very quickly. Then something is needed to insulate the planet, to somehow shield it from the cold of space, preserve this internal heat, and use it to sufficiently heat the planet to maintain water in a liquid state. What could this insulator be? Well, the simplest solution is that the planet be covered by an icy crust. After all, the planet is in the vacuum of space, in the cold of space, so it is plausible that it has an icy crust. The icy crust should be at least 10 kilometers thick for planets similar in size to Earth to preserve liquid water beneath this crust even for very long periods, billions of years. But beware, a 10 kilometers crust is a very thick crust, which would therefore require a planet with a lot of water. For example, if Earth one day were to be expelled from our solar system, cool down, and freeze completely, the icy crust caused by all the water on Earth would certainly not reach 10 kilometers. So, if our planet were to be expelled from the solar orbit in the future, it probably would not be able to maintain liquid water inside, except perhaps for pockets of localized liquid water, for example, around hotter areas like volcanoes. However, we do have examples of icy worlds that actually have large oceans of liquid water under an icy crust. We have the case of the icy moons of our solar system like Europa or Enceladus. These moons manage to maintain an ocean of liquid water inside them just under the icy crust, thanks to the internal energy produced in this case by tidal interactions with the giant planets, Jupiter, and Saturn. Another way a wandering planet might maintain water in a liquid state is by imagining it insulated instead by a very thick atmosphere. For example, a hydrogen atmosphere, which is an element that remains gaseous even at very low temperatures. Thus, even in the dark of space, far from a star, and is very effective in warming a planet's surface, provided, however, that this hydrogen atmosphere is very dense, dozens or hundreds of times denser than Earth's atmosphere. Both options, both the presence of an icy crust and the presence of a thick hydrogen atmosphere, are absolutely feasible options. So, there are no reasons to think that something like this has not happened or could not happen. If we take a step further, we might imagine that inside these oceans of liquid water, inside wandering planets, there could even be some form of life. Naturally, these microscopic life forms would not be able to use starlight, so, for example, they could not be based on photosynthesis, which is a very common mechanism on Earth for using energy. However, We know that on Earth there are mechanisms that do not use photosynthesis and that live in the depths of the oceans, around underwater volcanoes, and manage to exploit certain chemical reactions directly to survive and reproduce. Naturally, we are talking about purely speculative possibilities, but it's interesting to understand the limits of life and realize that it's not completely impossible that even a wandering planet, floating in the dark of the galaxy, could hypothetically host some form of life. The last question we might ask ourselves is, could we one day imagine directly exploring some of these wandering planets? This might seem an even more absurd and speculative possibility, but in reality, it's not as absurd as one might think. Paradoxically, it might be easier to reach a wandering planet than to reach a planet orbiting another star because, if we accept the statistical estimates that tell us all these wandering planets exist in our galaxy, there should be dozens, or even hundreds, within the volume between the Sun and the nearest star, Proxima Centauri. And all these wandering planets, which might be in our cosmic neighborhood and which we have not yet seen and which would be very difficult to observe, could hypothetically one day be reached with advanced propulsion means. However, for the moment let's content ourselves with observing these wandering planets from a distance and discovering as many as possible in the future. For example, NASA's future telescope, the Nancy Grace Roman, which is expected to launch in 2027 according to studies, could discover more than 200 new wandering planets. It might seem a bit sad to think about all these wandering planets roaming around, wandering in the dark of space without a star to warm them, and maybe this makes us appreciate our Earth even more. But at the same time, it also shows us that the universe is really very creative when it comes to inventing strange new worlds.